Alright guys, hey, welcome back to the shop. My name is Doug, and as in from the video you just saw, my sheet roll that I picked up about, well, almost a year ago. You saw the way it was set up. It was an all old wooden sawhorse, or just something they made to set that on. Ran a cog belt drive unit down to it. It was loose, hard to keep tight, slipped. So took all that off, put all that wood in the burn pile out back, and I want to make this. It mounts to my table. It'll basically stay on my table. This is the side that you would stand on over here, so it's going to be turned and just set along the edge. This motor, this came off of an old liquid transfer pump off of something. This is all scrapyard finds. You know, I go to the scrapyard every once in a while and walk around and find stuff. The gearbox drive came from a little conveyor belt. The motor I took off was about 1/3 of a horse. The gearbox on it was wore out, and you saw the belt slipping all the time. So I'm going to take this motor. This is a half horse single phase, and the gearbox is a 46-to-1 gear reduction. It still might be too fast for what I want, because the motor that came off of it's from a pump system, so it's I think 3600 RPM, something like that. 3480. So it's what you really need. You need a high RPMs, and then you need your gear reduction for your torque. I think it still might be a little fast for what I want to spin this at. So I don't know if I'm going to if I do it, I'm going to put a chain drive system on it, maybe 2 sprockets, run double chain, just to keep that chain in good shape. I'll use a number 40 chain probably. But right now I'm just going to try or attempt to kind of set this motor up on blocks of wood or something. And I want to butt these together, and then I'll probably just take a bunch of electrical tape and everything on it for right now, just to make a coupler out of tape. I want to see how fast it's going to spin, whether or not I need to slow it down. I do have the switch, and I have a foot pedal to operate it. I do have it wired up right now, temporary. This is just all the stuff I took off of it. So this is open and then closed. It's not a switch, it's just connects the circuit. So if something ever happens, take your foot off and the thing stops. That's the only safety thing on it. I mean, it'd be nice if it had a reverser. So I kind of wanted it to run in reverse, but this being a single phase, I'd have to go with a 3-phase 1 horse or something like that in order to put a reversing switch on it. Because that's what I thought about maybe doing. But to reverse it, I'd have a second pedal or a second switch to be able to go to, in case you get a finger stuck in it or something. But that's what this safety release is for. It just takes the pressure off that roller, and this here is just another lever. It helps you slip your piece off if you're rolling something in a cylinder, so you can slip it out. So if you get a finger in it, you got to be able to get your foot off the pedal and flip this lever. That way it takes the pressure off your finger. You're still going to get a crushed finger, but basically, don't put your fingers where they don't belong. So yeah, right now I'm just going to get this cobbled up. Okay, I got some painter's tape out, about 15 feet of it. Wrapped it up there by hand until it would grab, and then I just held the tape roll up here while it was spinning, just to give her a test. I think it's a little fast. I don't think that is the right direction. I don't know if I want it to run that fast or not. And it doesn't seem too bad. I'd rather have it actually quite a bit slower than that. I was just trying to get away from doing a chain and sprocket setup on it. Alright, scrounging around through some of my junk, and I used to mess with go-karts quite a bit and modifying the crap out of them. I was all about making them go as fast as I could, so I was always putting together sprocket combinations and stuff like that. So I got a bunch of stuff that's been around here for a hot minute. I found a 45 tooth 1-inch shaft all ready to go on, and just got to take this shaft out, that roller out, and cut a keyway in it for look like 1/4 inch. Or I can go with a 40 tooth, and I have this old bushing that I've modified for something else that I don't remember. It's not turned far enough for that. And this side here is turned a little bit too much. I probably made these back when I still had my South Bend 9 lathe. So that's been 3 years. But put this in the lathe, turn that down to that. If I want to go with the 40 tooth. But really, I don't care how slow it goes, honestly. I would like to see, I'll probably set it up with this one first. And this just has set screws in it. It also does have a 1/4 inch keyway through it. But I can lock that on for now. I found this, hell, I don't know how many teeth it has on it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like an 18 tooth. But it's still a 1-inch shaft, so I'd have to make a bushing to go from my 5/8. I'm pretty sure it's 5/8. If I quit moving the damn thing. Still have the key. Oh, no, this shaft's metric. I think it's an 18. Yeah. 18 millimeter shaft on this foreign jobby right here. So I'd have to go with make a bushing from 18 to 1 inch. Probably a little oversized even, so I'd have to make it tight. Yeah, so if I went 1 inch, it's on this caliper 9/99/5, so damn near an inch. But on this, 1 inch shaft, it's a little. That shaft's probably just wore out, so make a 1 inch bushing to fit here, and bore it to 18 millimeter to fit on here. All right, I get some material found and everything to make a bush for here. Get that made. All right, change of plans a little bit. What I'm gonna do, I found a piece of shaft, fit it, I had to sandpaper it off, I drove it on with a mallet. First I'm gonna go ahead and just weld this to the sprocket, and then I'll bore the hole. So where it's welded, and I'll face it off. I put a pretty deep chamfer in there on the sprocket, this side and this side. So I'll get that welded on, and then what I want to do, instead of using a key, I'm trying to think of a safe way to do it, to kind of have a little bit of protection. I'm going to put a shear pin in here, and then like a grade 1 or grade 2 piece of metal, or like a regular, like your cheap bulk fasteners, those should be a grade 2. So that's what you need on shafts for a shear, is they're plenty strong, but in a bind they should shear. So what I want to do is I'm going to make I guess you want to call it a pin out of that, or I'll find something else to make a pin out of. I think I have some mild steel, which is a grade 2. That I'm going to drill through it and then into the keyway, because I remember now when I found out this was metric, when I had it on something else, I set this up on I clamped this gearbox to a angle plate, and I machined that to a 1/4 inch key. So, and I don't have a broach set for metric. I'd have to use another size and then wrap some tin foil or something around it to keep it snug in the bush here, or in the sprocket, for me to key it. And I only have a 3/16, so I'd have to make the key from 1/4 inch to 3/16. So I don't have a 1/4 inch key that'll fit my broach bushing. So I'm just going to make a pin, which is going to be more than fine for this. And like I said, that's all threaded from a set screw. So I'll make a pin and use this set screw to hold it in to onto the shaft, and that should be plenty. Should be well strong enough for doing this. So I'm going to set this up on my weld positioner. I built this thing a long time ago, right here. Let's see here if I get you off the hold on, I guess I might be able to just turn it, kind of show you the goodies. And I got a weld burr. Oh, that was on there. I think you can see I made that. It is a motor from a treadmill with a switch and a fuse, the cord, all the little control boards in there. This is a cheap, really super cheap treadmill that I found in the trash that barely worked. I think the belt on it, or the tread belt was on it, was ripped or something. So I mean, I made everything. Had this chuck that I found in a scrapyard. It's not good for anything, so I destroyed it on the back. I didn't video none of it because I'd probably get all kinds of hate replies, destroying a buck chuck. But the back's all stripped. These jaws are actually welded to the piece that goes in there on the scroll, so they're not screwed in, so you can't take them out, turn them around or anything, because somebody plug welded them. And I don't know how really accurate they are, but they're good enough for what it does. So, you know, like it was maybe like a D6, I think, pin on the back, and I took the back plate off, and I had some other machine work to do to fit it to the plate that I have attached to the drive. So the motor in there spins on a sprocket. There's a chain drive, a big sprocket underneath of there to get this thing to travel really slow. It's not slow enough. I'd rather have it run faster so I can dial it back down to a speed for welding. But right now, the speed that I have it set at is its lowest setting. And I mean, I'll just turn it on here and it'll, you know, it's turned so far down, I actually have to turn it up to get it to start moving. And this is all the way turned up. I mean, anybody that can weld that fast, you know, more power to you. I need more gear reduction to slow that down even more, because I have to turn it all the way down to its lowest setting. It'll slow down and just barely creep. And it's still plenty strong. I mean, I can hold it there a little. I could stop it, but spinning something, it'll be fine. But that there is almost, that's still too fast for TIG weld. So, you know, people that make these, I see them spin, and they, you know, and you never hear nothing more out of them, how they worked or anything. I've seen a lot of videos on YouTube, you know, and the slowest they can get them to go is, you know, probably right around here or something. That's just way too fast. So there's the lowest setting. I don't know how many RPM that is, but I can weld MIG that, you know, traveling that fast. So, and also did make it, see, this chuck is only held on, there's a couple bearings down in there, and then I threaded the shaft with I think a 1/4 20 bolt or screw, I mean, and I have a pretty taut, like a machine spring down in there, and I just crank down on the spring to hold the chuck on. So I can wiggle this chuck just because of the spring that's holding it down onto the plate. But it's also, you know, keyed. It slides up and down. You know, I can pull it out, but it's basically being held in there by a spring tension. I had it rigid, but it was, something wasn't quite, you know, and it would rub, it would suck it down too far. So I just wanted it as tight as I can get it to where, you know, I'm probably a 1/16 of an inch off of that plate of it spinning around. So it's not too bad, but, you know, then I also did it that way so I can, this thing's probably 100 pounds, maybe a little more. I mean, that's a 9 or a 10-inch chuck. So that chuck's heavier than crap already. And then everything else that I got inside there, you know, I got the motor. The motor spins a gearbox with a gear reduction, much like what I got on here now, that I'm going to use on my slip roll. So, and that's the only bad thing about the way I mounted it. I don't have any clear through hole. So that's kind of what sucks. That's as far back in as I can go. And the chuck wiggles on there a little bit because it's only held on there by spring pressure. I mean, first time making it, it works for everything I needed to do. I wouldn't mind it being more rigid or making the mount that spins in there more rigid somehow, so this can be bolted to it a lot easier. That's what it is. I think you can just barely, actually I could probably speed that up for MIG. So it's got a little bit of run out to it, but for MIGing, you know, even TIG welding, I could TIG weld that probably. I don't know, it's moving a little fast now. Turn it down a notch. It takes a minute for it to get to its running speed. That's just something I thought I'd show in the video, you know, something I made. And I'll go ahead and get that welded on. And then I take it to the lathe. Since I chamfered so deep, I can face that off and get rid of all the weld look to it. And bore a 18mm hole in it.